I get going on that. We need to talk about the MCAs. Again, in the blue, back of the room, for third hour. Juniors, you're going to stay here. Make sure you have a fully charged Chromebook. One of the rules for the MCAs is you cannot have a cord on your Chromebook while you're testing. So make sure that it's fully charged before you come to class. Everybody else is going to go to the Media Center. They already have a list down there so they can take attendance when you get there. And basically you have a study hall Monday and Tuesday if you're not a junior. In math class we'll have a study hall. Now that would give you the opportunity to do things like take the formative that some of you still haven't taken for 8-4 and to catch up on your homework from 8-4 and 8-5. So those are good things to work on when you're in the Media Center on Monday and Tuesday. I also need to let you know, they're advertising this a lot more this year. The MCAs sent us a reminder that you can wear headphones. The problem is, they have to be just basic headphones. I don't think anybody has those anymore. You can't use your AirPods, you can't use anything that's Bluetooth capable. You just have to have your parents' old clunky headphones that just hook in and you can listen to whatever the computer's doing. Now, the only reason anybody would ever use those, I did have a student one year who had some really low reading skills. And they got to a problem that involved the word inequality, and they didn't know how to pronounce it. And so I had to pronounce the word inequality for them, and then they went, oh yeah, I know what that is. So that really is the only time anybody would want to hear the test taking place. But sometimes it helps. You never know. Every once in a while something clicks. So know that that's available. We don't have enough headphones to give to all the juniors. So if you have your own pair and you want to listen, make sure you bring that in for Monday and Tuesday of next week. Now let's push forward on adding and subtracting rational expressions. And we went through all of the addition, but like I said, we didn't get to subtraction, but it didn't worry me too much because all you have to do is change it to adding a negative. So this is the only example we're going to do on the subtraction ones. Like I said, I know there's 2 more down there, but we'll just do this one because this is the longest one of the 3. What is the difference of the 2 rational expressions in simplest form, and then state any restrictions on the variable? The first thing we're going to do with this problem is change it to adding a negative. So I'm going to leave the x plus 2 just like it is on the top of the fraction, but then I'm going to change it to adding a negative of x plus 2. Typically our first step would be, let's factor the denominators, but the first step on subtraction is change it to adding a negative. Otherwise, you risk that most common mistake in mathematics, which is negative mistakes. It's the most common mistake made. Now I look at x squared minus 2x. First thing to check for factoring, greatest common monomial factor. What could we pull out of that? Yeah, let's take an x out. Now it's in factored form. 2x minus 4. Can we pull out a greatest common monomial factor out of that one? A 2. Now the reason for that is we need to find our LCD, just like we did when we were doing addition problems. And we have those 3 pieces we're looking for. Are there any stray numbers off there by themselves that are not in parentheses? Yeah, we have a 2. Are there any stray variables that aren't in parentheses as part of a binomial? Yeah, there's a little x here this time. And then, of course, we need the binomial to its highest power. But both of these were little first powers, so the first power will do it. So now, before I start building these up, I'm going to go ahead and distribute this negative, because if anybody's going to make a mistake on this problem, that's where it's going to be. Up so they both have the common denominator. This one has the x and the x minus 2, but it doesn't have the 2, so it's going to need a 2 on the top and the bottom. Second fraction has the 2, it has the x minus 2, but it's missing an x. So we're going to have to multiply by x on the top and the bottom. Now, in the numerator, we're going to go ahead and distribute the 2. But in the denominator, we're going to leave it in factored form, just in case we can do some canceling later. And then we'll be very careful when we distribute the x so that we keep track of those negatives. Negative x squared minus 2x over 2x times the quantity x minus 2. Well, we can clearly see we have a common denominator. We can go ahead and do the addition across the top for our numerator. We're going to get negative x squared, and then 2x minus 2x will be 0, plus 4 over 2x times x minus 2. You know what? Yesterday, I did the domain restrictions right away. Let me stop right now and go back up there. Maybe you already wrote them down. I'd like to keep it in the same format that we did yesterday. So give me a number that's out. 2, definitely out. Another one? 0. Any more? We should have as many restrictions as we have x's. So 2 would be bad, 0 would be bad. All right. Now let's move forward. I don't know if I can factor that. The numerator is written kind of weird. So maybe if I pull out a negative, maybe I can factor it. So let's take a negative 1. Out of that numerator. Does that change it? Is x squared minus 4 factorable? It is, isn't it? It's a difference of 2 squares. So we might be able to do some more with this one. X plus 2 and x minus 2. So what do you see? Yep. Now that we can see the multiplication, we can use canceling, which is a form of division. But we're still going to have a negative on the top with the x plus 2 and a 2x on the bottom. Now, I don't need to distribute that negative through the parentheses. I could, it wouldn't be wrong. But we needed to take it out so that we could see that it was still factorable. And since we already did the domain restrictions, we're done. As long as our least common denominator works all the way through the problem, there's no more domain restrictions. It really is just adding a negative. You have that extra little step of making sure that you distribute the negatives, and then you'll be okay. It's not new concept at all. But we do have a new concept today. And they kind of included it in our objective because our objective was add and subtract rational expressions. What about when they look like that? Woo! A blank is a rational expression that has a fraction as its numerator or denominator or both. Complex fraction. So that name sometimes scares people. Complex, doesn't that mean that it's really hard? No. It's not complex because it's hard. It's complex because it has different pieces that we have to work with. So up here, they're showing us this is a complex fraction. We have some addition to do up here to get that to be a fraction. This is a fraction. A fraction divided by a fraction is a complex fraction. That's what it is. Same thing here. Fraction divided by a fraction. Look at this one. Fractions divided by fractions. Whew, that one would be huge. But we're not going to focus on that one today. We're going to focus on some basic complex fractions. What we need to do is simplify it. So what does it look like when you're done simplifying a complex fraction? You have one numerator, one denominator, and you're done. So you've cleaned up all the additional fractions that you see in here. and it just looks like one fraction when you're done. So it says you can simplify a complex fraction by multiplying the numerator and denominator by the LCD of the rational expressions. We don't do that in Algebra 2. We do that in pre-calculus, and we do that in college algebra. What we're going to do is use the exact same skills that we used yesterday to get these to be one fraction. So like it says, you can also simplify by simplifying the numerator and then simplifying the denominator and multiplying by the reciprocal. The purple, that's stuff we already know how to do. That's what we're going to do today. We're going to use that method. So problem 4 says, let's do some simplifying of this complex fraction. What is a simpler form of the complex fraction? So here's our job. There's 3 steps to every one of these. First, simplify the numerator. So I'm going to put a capital N for that. Second, simplify the denominator. Third, multiply by the reciprocal. I'm going to use the R for that, for reciprocal. Actually, let's do XR. So it'll look like times R, although I think using X is full. All right, so first things first. We need to make this numerator into one fraction. We did that yesterday. Those denominators are already in factored form. We just have to figure out an LCD so we can add them. So our LCD for the numerators will be X and Y. We have to have both of them. Well, that means this first little fraction is going to need a Y on the top and the bottom. And this second little fraction is going to need an X on the top and the bottom. And then we'll see what we get. So it'll be Y over XY plus X squared over XY. Again, just multiplying the numerators. Well, now I can add them together because I can see, hey, I've got least common denominator taking place here. It's going to be X squared plus Y or Y plus X squared. That's what we get when we simplify the numerator. Couldn't help it. While I was reading through this, I'm thinking, do they want me to give them the restrictions in the domain? Do you notice how they didn't say to do that anymore? Because we're going to have enough to do with complex fractions. They don't want to make us do that. We could, but they're saying, no. Just figure out how to work with complex fractions today. All right, that's the numerator. It's ready to go. We're not ready to go because we still have to do the denominator. So the denominator has 1 over y plus 1. But if I'm going to make that one fraction, I need to think of that as 1 over 1. Because I have to have a common denominator. What would my common denominator be for those 2 little fractions? Yeah, just 1 y. That's it. So my LCD for these, I don't even write down the 1. I need a y. That's what I need. The first fraction already has it. Don't need to make any changes. But the second one, going to need a y on the top and the bottom. And then we'll have 1 over y plus y over y. And we can clearly see they have the same denominator, which means we can add across the top. So you could write 1 plus y or y plus 1. Won't make any difference. Here's our little fraction. Step 1 was numerator. Simplified that. Piece of cake. Step 2, denominator. Simplified that. Piece of cake. Step 3, change the division to multiplying by the reciprocal. So we're going to take the numerator, x squared plus y over xy, and multiply it by the flip of our denominator. That's where we get the reciprocal part from, the flipping. Now, since we're multiplying, if we see anything in the top and the bottom that's being multiplied that we can cancel out, we're supposed to cancel it. So let's see, x squared plus y, that has addition. I can't do any canceling there unless I can factor it, but there's no way to factor x squared plus y. Y, that's as basic as it gets. It's in factored form. So is xy. Y plus 1, again, I'd have to see a perfect match in order to cancel that. The only thing I see is there's a y in the numerator and a y in the denominator that I can cancel out. No other factored forms that we can see that would cancel. And then you do top times top, so it'll be x squared plus y times 1, which is x squared plus y. Bottom times bottom, x times y plus 1. But notice I'm not distributing that x because we want to check one more time. Could we cancel anything out? The answer is no, because there's no way to factor x squared plus y. So that's done. It's finished. So it's like doing 3 mini problems from yesterday in one problem. That's what a complex fraction does. So let's go ahead and take a look at A down here. N D XR. Numerator. Well, I don't have to do anything with that. That's already simplified. It's an x. Love it. No work there. Denominator. Is that going to require a little work? A little bit. Not a lot. A little bit. What's our LCD? It is. It's xy. So that means the first one's going to need a y on the top and the bottom. And the second one's going to need a little x on the top and the bottom. Are we good to add those two together? Both have the same denominator? Let's do it. I'm going to put x plus y over xy. Just keep it in alphabetical order. But you could put y plus x, it wouldn't be wrong. Oh, we're all ready to times the reciprocal. So the numerator was x, but it might be easier for everybody if you think of it as x over 1. Because when you work with fractions, it's usually easier to have everything be a fraction. And then I have to flip my denominator. And then I have to check. Anything we can cancel. Nothing. Not a doggone thing. So we do top times top. Over bottom times bottom. And we make one last check. Is there anything we can cancel? No, there isn't. No, not with that plus in that denominator. We'd have to see a perfect x plus y up there in the top, and there's no way to factor one of those out. So for a complex fraction, that wasn't too complex. That wasn't too bad. Well, now we have to do this one. This is going to take a little more work, and I know that I write really big, so I'm going to cheat. Move that down. Give myself some more space. All right, there it is. What do we do first? N, numerator. Second, D, denominator. Third, XR times the reciprocal. All right. So let's take a look at that numerator. Do we need to factor the denominators? Already factored, right? Nothing we can do. So it's LCD right away. We have to figure out what the LCD is going to be. What are we going to have to use for this one? X and x plus 1. Yeah, we have to use both pieces. The first one has the x, in the bottom, but it doesn't have the x plus 1. So we're going to have to multiply the top and the bottom by x plus 1, which means some of you might want to put some parentheses around that x minus 2 piece there. And then the second one already has the x plus 1, but it needs an x. So let's see what we get. If I have to multiply x plus 1 times x minus 2, that means I have to use FOIL. Yep. Every kind of multiplying that we have is fair game. X times x is x squared. Outside times outside is minus 2x. Inside times inside is plus 1x. Negative 2 plus 1 is negative 1x. Last times last, positive 1 times negative 2 is negative 2. And in the back, all we have to do is write 2x. But we can see they've got a common denominator. Now I can go ahead and do that addition. So the only thing I'm going to be able to do is combine like terms with the x's, but it's something. So we'll do that. X squared plus x minus 2 over x times x plus 1. So that's step 1 with a lot of A, B, C, D going on. We had to get one fraction in our numerator. Now, quit thinking about that one. Now think about the denominator. And as I'm writing this one down, I notice, oh, that has subtraction. I better change that to adding a negative right away so I don't mess up. Are the denominators already in factored form? Okay, so what is our LCD? What's it going to have to be? Yeah, we're going to need them both. So the first one has the x minus 1. We're going to need an x plus 1 on the top and the bottom. Second one has the x plus 1. We're going to need an x minus 1 on the top and the bottom. On a big line, so I'll remember that was my numerator, this is my denominator. All right, let's go ahead and distribute in the numerator. 3x plus 3 over x plus 1 times x minus 1 plus negative x plus 1 over x plus 1 times x minus 1. Our denominators match? Let's go ahead and do the addition. Let's see what we get. 3x plus a negative x is 2x. 3 plus 1 is 4 over the quantity x plus 1 times the quantity x minus 1. Now at this point, does anybody notice that we could factor out a 2 out of the top and the bottom? You see that? Let's do it. Let's take care of it right now. Even though we know nothing's going to cancel. Might make the next step much easier. So factoring is still the last thing we're doing to see if we can simplify. All right, what did this stand for? All right, so here's our numerator. We write that one down like normal. We have to flip our denominator. Now at this point, I hope there's something you're going, I wonder about that one. Which one has you wondering? Right, the trinomial. Maybe it's factorable. And if it's factorable, maybe we'll be able to cancel out a lot more stuff. So let's see. It's definitely not a perfect square trinomial. But do we know two numbers that multiply to -2 and add to 1? Ah. So maybe, just maybe, that'll give us something additional we can cancel out. Now, the reason that I didn't factor that up here, right at this spot, is because some people like to factor it right away. Some people like to wait until they get it all as part of one big fraction. It's up to you where you do it, but just make sure at some point you have that in factored form so you can do a boatload of canceling. What do you want to cancel? X plus 1. What else? X plus 2. Anything else? That's it. Remember, it has to match on the top and the bottom. Doesn't matter which fraction, but top of one, bottom of the other. So let's pull together what's left. We have an x minus 1 times x minus 1. We want to write that as x minus 1 squared, now that we're trying to simplify this. What are the only things we have left in our little denominator there? A 2 and an x. All right. Numerator, denominator, multiply by the reciprocal. That's what we have to do. So, the other thing I keep thinking about is, with tomorrow's lesson, please make sure if you haven't taken the 8-4 formative yet, that you write yourself a little note. Monday and Tuesday, if you're not a junior, take care of that when you're in the media center. Get that done. Here are some complex fractions to try. They're not all going to be like the last one we did. The last one we did was definitely the most complicated one. In fact, I don't think I gave you any that were that complex. Because we don't test you on the really hard ones, the ones that have a ton going on. We test you on some basics. Would almost be in the category of the last problem that we have. It's a little easier, still a little bit easier. So these are all very basic except for number 29. I'll take the other one to work on. For the rest of them, we can just fine. 31 to 34, that's review of addition and subtraction. 41 is a nice basic complex fraction. And 62 to 65 are solving for just review problems. So, they're not all big long problems. None of them are like the last one we just did.